And hello, welcome back to this video. So today we want to continue where we left off the last time. We were left with these equations which they were like half non-dimensionalized. So the next thing to do, okay, we might want to do something about this u infinity over L. Alright, we might want to like divide throughout like that. But before that, let's non-dimensionalize the time. So this t here, how do we non-dimensionalize time? This t here equals to t star times L over u. Okay, so let's just write that down. Okay, t star. Okay, so the L is at the bottom and the u is on top. L is at the bottom, u is on top. Okay, L is at the bottom here, u is on top. Alright. So let's do u infinity L. So this is how we non-dimensionalize the t, the time, as we were saying before. So that's where we have a t star, L at the bottom, u on top. And it's just like this when we bring this over. L will be at the same side as t, u will be like inverse. U will be at the bottom. And when you take 1 over t, alright, you take 1 over t, you will get this effect. Okay? So, and we see this u infinity over L being quite a common denominator. So what we want to do is divide throughout again. So let's divide throughout by u infinity over L. Okay, let's divide throughout by u infinity over L so that we can get rid. Okay, so that's 1, that's 2. So this we need to multiply L on top, u infinity at the bottom, L on top and u infinity on the bottom. Alright, and this term we need to do it. Next is this one, this viscosity term, L again, L on top, u infinity at the bottom. Okay, L on top, u infinity at the bottom. So that will be multiplied into this viscosity term here. And likewise, we multiply L on top here, u infinity at the bottom here. So L on top, u infinity squared at the bottom. Alright, we're almost there. Okay, so what do we notice about this? V, L, delta P, and u infinity. How did we scale our momentum equation? So we had this V star here. V star equals to V times L, because a dividing a reciprocal of a reciprocal, or you divide a 1 over x. You take reciprocal of 1 over x, it'll just give you x, right? So you shift this L on top. So VL u infinity delta P. Okay, VL u infinity and delta P. What does that give you? V star. So this whole group of things here is actually V star. Alright. So what can we do next? V star is there. And we probably want to simplify this part because there's a lot of L over here. We might want to just factorize out this L squared just to make things a little bit neater. So let's factorize out the L squared. So L squared will be factorized out, and then you get L at the bottom. Okay, so nu over u infinity L squared. So let's factorize out the L squared, and over here we take out the L squared, then we multiply it in on top. Yeah, we factorize it 1 over L squared. Okay, and yeah, oops, sorry. This should be this over here should be L, not L squared, because previously you were how do you say? Yeah, previously we were just having a L on top there, so you kind of just need to cancel that out. Let's go. And what do we notice? This here actually is a Reynolds number. Nu over UL is actually 1 over the Reynolds number. So let's do the Reynolds number thingy there. Okay, Reynolds number. So RE. Okay, this one is with the subscript L, which is of course in the x direction. Okay, U infinity L over nu. Alright, so that's our x direction Reynolds number. So we just got to be very careful with, because we can define Reynolds number a lot of ways. So we use the subscript L here. Okay, so again what we're doing, we multiplied everything throughout by this U infinity over L, and then we get this V star over here. We get we multiply by L over U infinity, sorry. Then we get nu L over U infinity, then we kind of factorize this part out, and of course we multiply L over U infinity here as well. Alright, so a few nice numbers should be popping up. Okay, so but first, before we do anything, let's replace it by REL at the bottom. Alright, so that's where this Reynolds number actually pops up. Okay. Alright, so that's 1. So then you have L squared over delta P squared. Then you have this thing here, which you can kind of just multiply in. Let's just multiply this in and see what we get. I'm not going to take out the gravity terms yet. Of course, you can assume that to be 0. But before that, I actually wanted to help kind of get something, right? Help do something. There's another dimensionless number is going to pop up. Okay. Okay. So let's scale gravity. Okay, this just this is not usually part of the boundary layer equations. So let's do gx star equals to gx over your gravity. These pertain to body forces. And I'll show something a little bit more interesting. Okay, so we can substitute this in, and of course we can actually get rid of the L's over there. So L and rho naught will disappear. I mean the L on top and the L at the bottom will cancel out, and gx will be gx star times the magnitude of G, which I can just put on top. This is the magnitude of the body force. Okay, however you angle it, however you angle the components, okay, gx star is going to be on the order of magnitude of 1, because gx compared to G, I mean this is just basically like a sine of the angle between the x direction and gravity. So, or cosine, yeah, cosine of the direction. So this gx star is, you can think of it as a cosine theta, and cosine theta is on the order of magnitude of 1. So this should be on the order of magnitude of 1. Okay. Okay, theta x. We'll just call it theta x. This is the angle between the direction of gravity and the x-axis. All right. So this is a basic physics thing. So yeah, and this will be on order of magnitude of 1. All right. It varies from 1 to 0, so it's the order of magnitude of 1. Alright, there's a few interesting things here. You see a rho u square, rho u infinity square. Alright, that is one interesting thing, and that is what you're going to use to scale pressure. This is somewhat of the dynamic pressure. Well, of course, dynamic pressure you kind of use half rho u squared instead of rho u squared, but it's but that kind of just differs by a factor of half. This over here is an interesting number. All right, this over here is an interesting number. Okay, so what is this number here? Well, if you take a look online, you look for something called the Froude number. Okay, Froude number. Okay. Froude number is u over square root of GL. U over square root of GL. You have a L and G here, and then of course u squared. So that is just nothing but the inverse of the Froude number squared. Okay, I'm going pretty fast with this, but this is how we find that this interesting dimensionless number pops up. It's called the Froude number. Froude number actually measures the initial forces compared to the gravity or body forces. Okay, so Froude number. Okay, this is just something for your information. All right. So where gravity is negligible, you have huge Froude numbers. Okay, where gravity is small compared to the velocity, Froude number is huge. So Froude number is over here. Okay. So when you have huge Froude number, this whole thing actually disappears. Okay, so that's how we kind of make our gravity term disappear. The other thing here is that we want to scale our pressure. Okay, pressure, the easiest way to scale is of course P star equals to P over, well, rho u squared. Rho naught u squared. Rho naught is the density, reference density of the fluid. For incompressible fluid, you can use rho or rho naught, doesn't really matter. Okay, but this is how we will scale our x momentum equation, and we are more or less done. All right, so there we go. Okay, we scaled our x momentum equations there. Okay, and there, Froude number. So after non-dimensionalization, our x momentum equation becomes like what you see here. Okay, so this is our x momentum equation. So 1 over Reynolds number here, 1 over Froude number squared. Everything else is kind of constant, and then you have this delta p over L squared. Now the question is, of course, how do you deal with this thing? Okay, how do you deal with this L delta p over this L squared over delta p squared? Because this is a pretty large number, and at the moment we don't really know how this number L squared over delta p squared actually compares with this Reynolds number over here. Okay, so before we talk about how to deal with this, let's try to also do the same thing for the y momentum equations. Okay, the y momentum equations. So that's gonna be a bit of the other a bit long as well. Okay, so we dimensionalize y momentum equations. Okay, so we'll do more or less the same thing here. And now the good thing is that we already the good thing is that we already know how to non-dimensionalize all these variables. So let's just start with that. Let's start with the x-coordinate stuff first. Okay, we start with the x-coordinate stuff, and of course time. So x will be x star into L, as said before, x star into L, and U will be U star into U infinity. So U infinity over L. So that's part 1. And for time, as said before, time is actually T star into U. T star into L, T star into L, and then U infinity will be on top. That's what we were doing slightly earlier. Okay, this is the Y coordinate thing, so I'll leave it for later. Okay, this x squared will be x star squared into L squared. Okay, so let's do that. 1 by L squared over here, and the rest basically deal with Y. The rest deal with the Y coordinate. So let's do that in the next part. Alright, so let's first the x and time terms, and then the second Y coordinate terms. Okay, so let's deal with the Y. Okay, Y is Y star into the momentum, how do you call it, boundary layer thickness. So fraction 1 over delta P. Alright, where else will Y pop up? Here Y will pop up as well. So let's do a Y star square. So Y star squared. Okay, so this one will turn into Y star squared. Okay, then the last place we have our Y is over here, so we'll need to non-dimensionalize that as well. Okay, 1 over delta P. Alright, so this is the last part. And of course, you want to put the gravity thing in there too, sure. 1 over the magnitude of the gravity, and that's what we can do as well. Alright, so that's basically deals with the Y coordinates, so to speak. Now again, next thing we want to do, okay, the next thing we want to do is to again fast forward the multiplication thing. So what we do is basically we divide by U infinity over L, but since in the last equation we did it twice, I'm just going to fast forward. I will divide by U infinity squared over L squared. Okay, I'll divide by U infinity squared over L squared. Okay, divide, factorize out. Okay, divide by U infinity squared over L squared. So I'm just going to divide this part out. So let's just invert it. So the first two terms will be L over U infinity. Second term here, L over U infinity. L over U infinity. Okay, I'm going to stretch this video a little bit. The third term here will be, you have L squared over U infinity squared on the outside. So let's do L squared over U infinity squared on the outside over here. This third term, Okay, L squared over U infinity squared. U infinity squared. Okay, so we'll just do it very carefully as far as possible. So this is what happens. Next thing will be the viscosity term, so we'll just multiply that in as well. L squared U infinity squared, and I might as well just copy and paste. Yeah. Here the right hand side you also need to do the same. Okay. The right hand side you'll need to do the same as well. Of course, this whole thing is gonna get a little bit long. Okay. What next? You kind of want to get rid of this delta p. So let's multiply by delta p. Okay, multiply by delta p. I'm just doing this so that it's making the equation look nicer, and after that the terms will get a little bit easier to cancel. Alright, so let's take this out. Okay, delta p in the first term. Okay, then after that delta p in the second term. So I'll just deal with this 3 first. Next will be delta p in this term here. Okay, so there should be delta p1, delta p, and then this one, the delta p of course disappears. So then delta p should also appear on the right hand side. Okay, delta p will appear here. Okay, what do you notice again here? Okay, maybe I should have divided by delta p instead. Let's see. Okay, based on our what do you call that? Our definition of v. U and delta p should be opposite. Okay, never mind. I'll divide by delta p instead. Okay, let's do that. Divide by delta p. So let's bring this to the bottom. The first one, second one as well. Then you will be able to see some so-called numbers, good numbers popping up. And delta p squared will appear on this third term. Okay, next one will be instead, you shift this thing down. Okay. Alright, so that's next. And of course the right hand side, you will have delta p at the bottom as well. Okay. Okay, what next? Okay, now we see that we can actually start combining some terms. Okay, the v will become v star. Okay, combining some terms. Okay, the v will become v star on this one because vl u infinity delta p, that's actually v star. That's a non-dimensional form of v. So that takes care of one a few bits of headaches. Alright, same for the second term. The second term here, you also see the same effect. Alright, the L and delta p as well. Third term, you'll see that there are two v's, one that's getting differentiated by y star, one that's not. Both of them can be reduced to v star. Okay. Alright, so that's one. Next term here, we can actually bring in the delta P, U infinity, and L into both of these V's here, and that will non-dimensionalize them. So L over U infinity will stay outside, delta P will be gone, and let's just non-dimensionalize the V stars, which are over here. Okay, last one here, well, there isn't any so-called thing to really how do you say, there isn't anything over here that really enables you to deal with y coordinate stuff. But okay, yeah, we'll need to deal with this part a little bit later. Okay, but you can see these terms here are all nicely non-dimensionalized. Okay, here we almost have a Reynolds number kind of looking term, so we'll need to factorize out L squared again. So let's factorize out L squared. Okay, let's factorize out L squared. And we'll get this. Okay. And we'll again have our L squared over delta P squared. Okay, and here we almost have something that looks like a Reynolds number, but it's not really quite there yet. Okay, so let's bring this out. Okay. Or rather, yeah, let's just multiply this in, and we'll see what happens. Okay. I'll just multiply this in. Okay, I think this new can go on top. Okay, we should be able to get some semblance of a Froude number pretty soon. Okay, so anyway, you see the rho and U infinity squared will be able to non-dimensionalize the pressure. Pressure and including the Froude number. Okay, this one will actually just reduce to a Froude number as you. Okay, okay, where's the Froude number? Froude number is here. Yeah, this same Froude number. So let's non-dimensionalize pressure first. And yeah, over here we can actually use the Froude number. So Froude number is G times L squared, yeah, or G times L, sorry, G times L. Did I do something wrong? I hope not. Anyway, G times L over the GL over U. So G should be on top. Hold on, I think I did something wrong there. Yes, this G should be on top, not at the bottom. Yeah. Let's see. It's a little bit to replace G star into G. Okay. Kudos to you who actually, to those of you who actually spotted my mistake before I did. So good job, they are paying attention. Let's just replace all of this first. All right, it's and the last one will be here. And then we should be able to get our Froude number up and running shortly. G into G into L over U squared. So over here we have this Froude number squared at the bottom and L over delta P. Alright. So the U infinity disappears. U infinity at the bottom disappears. You have L over delta P, and I'll just have 1 over the square of the Froude number. Okay, this will become the Froude number and L over delta P. Okay, so I wonder if this thing here actually, yeah, I think it will come out later. All right. Yeah, and I seem to have forgotten to multiply this delta P in. There's this delta P over here which needs to be multiplied and it needs to be squared. Okay. And just to tidy up, I'll just get rid of these fractions. And there you have it. Yeah, more or less the y equations have been non-dimensionalized. Okay. So thanks for watching. I'll talk about how to reduce this even further. You can include Reynolds number in the next video. Okay, but this is it for today. I'll see you again.